Good afternoon to one and all. I am going to take a topic of data structure today. Before entering into the topic, what is data structure? Data is an information and structure is how the informations are stored in a linear order. The data are stored maybe in ascending order or descending order, but our main agenda is to data are arranged to reduce the wastages of memory. That is our main motto. So informations are stored in any order in form of to extract the data in a quick manner and also to reduce the wastage of memory. This is the main agenda of the data structure. Okay, so data is here information. So data is an information and structure is for arranging that data in a linear manner. Okay, for that arranging the data and the data structure, there should be two types of data structures available. One is linear data structure and other one is a non-linear data structure. What is linear data structure? Linear data structure is arranging the data in a constant, in a continuous way, in a continuous memory. But non-linear is not to arrange the data in a continuous manner, but it will store the data where the free faces are available. It can store the data in that free faces. That is the non-linear. Okay, in that linear we can able to have a number of linear data structures like list, stack, queue, list, stack, queue. These are some of the examples of linear data structure. These are the how the data are arranged in a linear orders. In non-linear we can able to show as a tree and graph. Tree and graph. These are the major examples of the showing our non-linear data structures. Okay. Today we are going to see about that linear data structures today. Okay. Today I am going to take a classes on list. What is list? List is a collection of items. Data can be stored in a linear order. Okay, in list we are having a concept of abstract data type. What is abstract data type? Abstract data type is here modules are splitted into submodules, so we can able to solve the problems in an easiest way. That should we are going for that of ADT. ADT is nothing but abstract data type. So ADT's full form is that of abstract data type, where we can split the data into that smaller module. Why we are splitting the data into smaller module means for arranging the data and also for recovering the data in the needed situations. Okay, in list we have different types of list. There should be three types of lists available. First one is here these are different types of lists we can show. One first one is a single linked list, second one is a double linked list, and third one is a circular linked list. In single linked list, the data are different operations are carried out. On single linked list, the insertions and deletions can be taken place at any one of the end. That should be that of single linked list. But in doubly linked list, insertion and deletion can be taken place at any ends, at both the ends. that is a doubly linked list. In circular linked list, there should not be an endpoint, there should not be any null pointer. The data are stored in a circular manner. Okay, this is a types of linked list. Okay, where the insertion and deletions are taken place at any one of the ends, that is single linked list. Insertion and deletion taken place simultaneously at the both the ends is doubly linked list. And circular linked list, the null node is not present and data are stored in a circular manner. Today first we are going to see about the single linked list. There should be n number of operations or carry out in different types of list. We have to check whether it is empty, insert. That insert itself, there should be data can be inserted at the end or begin or middle of the list. For delete also we can able to check whether the data can be deleted at the end or at the starting point of the begin or at the middle. These are the operations where we empty, insert, delete, and to search, find. That find we can able to show the find maximum operation or find minimum data. That should be our find it out in that of single linked list. These are the various operations taken over in a single linked list. Before a single linked list, a list is a collection of nodes. What is list? A list is a collection of node. A list is a collection of nodes. Okay, what is node? A node contains a data and then address of the next item. This is a node or collections. Okay. For example, this is a node. The node can be split into two data. First one is here represent the data, and second one is the next pointer. A node contains a data and the next pointer. A data is an information and next pointer represent the address of the next node should be stored in that year. Okay, this is a single linked list. Okay. We can able to draw a small example for that of single linked list. It should be header, these are the datas. Okay, though the node contains two datas. First one is here data and other one is the address of the next node that should be presented. For example, this is a node, their address is 1004. So the address should be stored in front of that node. Okay, this is a single linked list. In the single linked list, the last node should be that of always null because no data are available then other than null. So we can represent it as null here. Okay. In the single linked list, we can able to insert the data at the begin, at the middle, or end of the list. And also we can able to delete the data at the begin, middle, and end of the list. Okay. For example, we just write a small code to find out the node or present or not. First, we can able to show This is a small algorithm for inserting the node in a single linked list. First we have to inserting the node. Okay, so the name of the node is that of node. Okay, for example, I just insert a new node here. Okay, so we have to allocate the memory for that node. So node equal to memory allocation for that of size of structure. So we have to allocate the memory for that node, and then we have to check whether the node is null or not. If the node is null, there should not be any data are available, so we can know further issues. If node not equal to null, so that some data are available in that node, so we can able to find, and we have to read what kind of data is present in that node. So node point a data equal to item. So node point a next, where that node next is given to that of next node. There should be node point a next equal to new node. So new node point a data. This is a new algorithm, simple algorithm where the how a new node is added to the top single linked list. For example, I just added a new node here. So I just given a connection to here and then here. Okay, therefore this 1004 will be represented here, and the data is that of 15, and the address is that of 1004 here, and the address is of 1003, means it should be represented here as 1003. Okay, so new address will be represented and new data should be shared here, and we can able to find out where how the data are stored in that application. Okay, this is a single linked list. This is similar to that of we can able to delete. For example, we have to delete means for deleting operation, the node we are going to delete named as node equal to temp. If the node is named as temp, we are ready to remove that node. That should be represented here. Okay, this is a single linked list, and our next one is a double linked list. Doubly linked list is nothing but insertion and deletions are taken place at front and back ends of the sites. So we can use the pointer as forward pointer and backward pointers here in the doubly linked list for inserting and deleting the data. Okay. For doubly linked list, always they should have the header. From that header, we have that node, the last node is always null, and you should have the data at the center, and the addresses are stored here, and we can represent this pointer is here. This pointer will be the front towards movers, so it should be the forward pointer, and this pointer is the backward pointer. Through this forward pointer and backward pointer, we can able to insert or delete the data wherever we need it by using this doubly linked list. Okay, for that in circular linked list there should be a small changes is available here. In circular linked list, we just without that null, the data are presented here. Here is 1002, that address will be stored here, and it should be given here. So data are circularly arranged between the transfer between the nodes is a circular linked list. Okay, and where the applications, how the linked list applications are working. In applications of linked list, it should be used in that of different types of data where the data are stored in a linear manner, and data are arranged where the frequent of data are task scheduling, for example task scheduling, this kind of operations we can use that of linked list. This is an first applications of first workout of the linear data structure, and second one we are going to study about the stack. What is stack? A stack is a single side open module in which data can be inserted and deleted at the single end. This is a stack, in which a stack is also represented as LIFO. What is LIFO? LIFO is the last in first out. What it represents, the last in first out, the data inserted last that should be taken out first, that is the last in first out. For example, it is we represented, this is an open single side open ended. Okay, therefore the data are stored like this order. The element in the top position we represented as top. So I have to remove the data, I have to insert the data, means it will be filled in a bucket manner. I have to remove the data, so which data is in the top? 50 is in the top, and that data is inserted last input, so it should be delete out. This is the first out, therefore it should be that 50 will be removed first. That should be that we represented as last in first out. Okay, this is the form of stack. Okay, in stack we are having different types of operations like push, pop, and then peek. These are the various operations we just carry out in that of stack. What is push? Push is nothing but the data are inserted, that is called a push. Okay, how the data are inserted? The data are inserted by using that of top. Before data is inserted, we have to check. For example, for push, we have to check whether the stack is empty or not. If the stack is empty only, we can able to enter the data. If the stack is full, we can't able to enter the data. So we have to, before entering the data, we have to check if top equal to full. If top is represent stack is full, means there should be overflow taken place. Overflow, so we can't able to insert the data, else we can insert therefore top plus plus, so we can able to add one by one data in a plus plus manner. So we have to push the data by using the concept of plus plus. Okay, so we have to delete the data. In that of next one, in the next operation for pop, we have to delete the data. So where is, what is pop? Push is insert and pop is delete. We have to delete the data. First we have to delete the data. What we have to check? If the data are present in the stack only, we can able to delete, otherwise we can't able to delete the data. Okay, so first we have to check whether the stack is empty or not. If the stack is empty, we can't able to delete the data, otherwise the stack contains some data. So if the stack is underflow, we can't able to delete. We have to check the condition of underflow, otherwise we can able to delete the data by using the concept of top minus minus. So by using this decrement operator, we can remove the data one by one. This is the operations of stack. Okay, stack can be inserted the data using the true concepts of array and also in linked list. We can use the stack using that of array and also in linked list. This is the concept stack using arrays. Okay, where the applications of stacks are using, applications of stacks are using in n number of applications. Stack is used in the function call and also in regression, evaluating the arithmetic expressions, Tower of Hanoi. So these are the some applications of stack where we can able to use the concepts of this stack, and also we are using in our real time environment. In this real applications for inserting the bangles in the hand, it's one of the main application of the stack where we can use in our real time data. So, okay, this is one of the importance of stack. Okay, and next we are going to see about that queue. This is the second concept of that linear data structure, and third one is that of queue. Queue is one of the important operation in linear data structure. We can able to represent the data using array and also in linked list. In this two concept also we can able to use it in queue. Okay, in stack we can represent as last in first out, but queue it should be named as first in first out. Stack is here last in first out. The element should be inserted at the last, it should be deleted first, but in queue we should be first in first out. Okay, the element should be inserted first, should be deleted at the last. Okay, this is an important concept of queue. Okay, so stack is here first in first out. For example, we are entering into the, for getting the cinema tickets, we are entering into the queue. That are the important examples of queue. Okay, this queue, it is an doubly ended one is for insert and other end is for delete. In the insert element is we can represent it as rear in a technical word. In deleting and the point represented as front. Rear is a position where we can able to insert the data, and front is a position where we can delete the data. This is where operations are taken place. Okay, for inserting the data, we have to check whether the queue is full or not. If the queue is already full, we can't able to insert any elements, the queue is overflow. Otherwise we can able to insert the data using the condition of rear plus plus. Okay, by using that rear plus plus we can able to add one by one data here. Okay, for delete can use front plus plus. So front is a point where we can delete the format of the data, where the point where the deletion can be taken place. So by using the front plus increment operators we can delete one by one data, so it can be remove all the data from that end. Okay, in this queue there should be different types are available. One is of circular queue. These are the types of queue. One is circular queue and other one is here doubly ended queue. One is circular queue and other one is a doubly ended queue. Okay, where the circular queue and doubly ended queues are working. In the circular queue we don't have any starting point and ending point. There should be not available any ending point, there should be a starting point. From that data can be inserted in that of linear order in a circular manner. For example, in the circular queue we have only one point where should be insert. There should be that of rear end is available here. For example, we should insert the data here. The starting address of array starts with the array of 0. Therefore, the data are stored in an rear manner. So, if the circular queue is free, automatically data are entered in an order. If this circular queue is full, automatically the first inserted data it will be automatically deleted in that circular queue. We can't able to need any front point to delete the data. This is one advantage of that circular queue. It will automatically deleted the first data that should be inserted first. That should be a major advantage of that circular queue. And also for doubly ended queue, in doubly ended queue, one of the major advantages insertion and deletion taking place at both the ends. We can able to delete and insert the data at whenever we needed at any ends. We can able to represent it by using that of doubly ended queue. This is a major advantage of that of doubly ended queue. Where the applications of the queues are available, applications this queue is used in n number of real-time applications like getting the tickets, cinema tickets, for lining in the queue, for standing in the queue, for that of in OS version of process management. How the processor, for example, in the OS scheduler, we just know the first come first serve, priority scheduling, and round robin scheduling, like that. Based on the queue order, it should be allocated. And also second one is of scheduler. Which process has to be taken place first, which process has taken place second, can be identified and should give the priority of the works. For example, we are watching the YouTube videos. When the income call is coming, automatically the running YouTube video will be in idle mode, and it will give the priority to that of voice call. That is one of the scheduler that is also taken place in that of queue. And for memory management, for where we have to allocate the memories for primary memory or secondary memory. For example, we are playing any PUBG games, automatically we consider the secondary memory as the primary memory, so we need it. Automatically it will schedule which kind of memory is needed, which kind of memory is allocated for that process should be identified and should be allocated by using that of memory management. And also for function calls, which type of function calls are represented. There should be a number of functions calls are available. For example, in switch case or in number of various if conditions are taken place over here, means which condition should be executed first. There should be priority should be identified by using that of queue in that of function calls. These are the various applications of queue where we can able to represented in that of applications. These are the overview of that of where we can able to store the applications linear data structures. So for list, tree and then graph. This linear data structure we just show the stack and queue in an explainable manner. Thank you.